Okay, so we're going to start on the study guide. Then if we already talked about number 6 on the other video, just skip past this part and then we'll get on with the rest of them. Okay, number 6, a student conducted an experiment to determine if solid zinc would react with aqueous lead 2 nitrate. She dropped a piece of zinc into a small amount of aqueous lead 2 nitrate solution. What do you think happened? Make a prediction as to what she found and how you know. Be specific. Okay, so here's the thing. On a question like this, the first thing I would want you to do is show me that you know how to write the reaction, if there is one. What did she start with? What are the reactants here? What do you think, Michael? Yeah, solid zinc. So Zn with a little bitty S beside it, solid zinc. And then they tell us that it's PbNO3 2. And it's aqueous, so we're going to put a little bitty AQ beside it, okay? Which just means that this is like a powder or a crystal that's been dissolved in water. It's completely dissolved. It should be like a clear solution or pretty clear. Okay, so then you've got to ask yourself, would this react or not? If the kid was going to make or did this, and you were going to make a prediction about what she found when she did this, first of all, what kind of reaction is this setting up to look like? What type? Single replacement. Good. And so we know that in single replacement reactions, things that are alike can replace things that are similar to them. So you always have to look at the single and ask yourself, is there something in the compound that is similar to what this is? What is zinc? Is it a metal or a non-metal? It's a metal. Is there a metal in this compound? Yeah, lead. Yeah, the lead too, right? So now the question becomes, could zinc metal replace lead metal and swap places with it? So what do you think? Yes or no? And how do you know? How would you know? Anybody want to be brave and take a guess? No. Okay, Brendan, try it out. What do you think? Yes, it would react. Would zinc be able to come over here and kick out lead?
No, it's less active.
Like, no, that's incorrect, but you got the right idea. You have to look at activity, right? How do you know, though, where the most active metals on the whole chart are? Where are they? Towards the left. And as you go towards the left, they get more and more active. And as you go up, they get more and more active, right? You see where zinc is, number 30? You see where lead is, Pb, number 82? So zinc is farther to the left and it's higher up. So zinc, you have to ask yourself about the single element. Is the single one more active than the one that's in the compound? Could it come in and kick this out and take its spot? And the answer is yes, because it's more active. Okay, zinc is going to take its spot, and that's all you have to really show. ZnNO3 to aqueous, and then plus what got kicked out, everybody? The Pb. And we also know that when you say it got kicked out, it really does completely switch spots, and the states of matter even switch. It becomes a solid. That lead would precipitate out. You would start to see little shards of lead that would crystallize all over the zinc. And we are going to try this reaction out when we get back from Christmas. Okay, the lead will start to precipitate out. It forms all these little crystals, and it almost looks like the zinc disappears, but it doesn't. It just dissolves in the solution. You just don't see it anymore. Okay, so having said that, then this would be fine as far as like, this is a good prediction because you're predicting what would happen. And you would say, okay, this would be a single replacement reaction. The lead and the zinc would switch places. The zinc would dissolve. The lead would become a precipitate, or if you don't want to use that big fancy word, you could just say the lead would become solid from the solution, and that would be fine. That's a good prediction. Okay? All right. Which speaking of that, Here's a similar question. Remember the one yesterday from the worksheet? The one about gold. What if you dropped a gold ring in salt water? Right? What did you think? I was really hoping you would channel all of your Pirates of the Caribbean. Pirates of the Caribbean? Which one is it? Caribbean? 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 Anyways, the Pirates movies.
That's where you're from.
Right? I know. Just like pecan or pecan.
Oh my gosh, people say pecan.
Pecan. That's people from deep south.
Caramel
Pecan.
or caramel.
Caramel, caramel. Oil or oil? All right. It's oil, people. All right. So anyways, what were we? Oh, yeah. What were we talking about? Gold. I was hoping you would channel all of your old pirate movies. If you ever watch a pirate movie and they discover gold treasure in the ocean, that gold hasn't dissolved, has it? No. Solid, pure gold is not affected by salt water. It won't be. Now, if you Googled it, Google will tell you that soldered gold will dissolve or be affected. And that is true, but soldered gold is like the kind that you wear. They put other metals and stuff into jewelry to make it more durable, which is, you know, the thing is, though, even this, like, I'm pretty sure my husband tried to spend some money, but this is not like high quality gold. You know what I mean? This is affordable gold. So, but I can take this in the ocean multiple times, and we have, and it's fine. It's not going to dissolve. People that make jewelry don't want to make stuff that's going to dissolve in the ocean. You'd have a lot of angry people coming back for you, right? Solid gold and silver, that's why they're used to make jewelry a lot, is because they won't dissolve or corrode when they're exposed to like salt water. So the answer would have been no yesterday, because gold is not more active than sodium. Gold is way over here. Sodium is way over there. It wouldn't be able to replace it. Okay. Hey, well, we got to move on. Number 7. Hey, what are the 4 indications that a chemical reaction has occurred? Dakota, do you know one of them? What's one indication? You remember one?
Change of color.
Yeah, change of color. Very good. Riley? Gas produced. Logan?
Production of odors.
Production of odor is a good one. What's another one?
Change of color.
Yeah, change of color. How about Seamus? Very good. A precipitate form. Do we miss any? Yeah, temperature. Energy is evolved. Very good. Okay. So all of those, we actually listed like 5, but any of those 4 would work. The evolution of energy, color change, odor change, precipitation, and then whatever else one I didn't say that I forgot already. Okay, number 8. In order to balance a chemical equation, so number 8, what is the only number that can be added, removed, or adjusted? What do you think, Bart?
The one in front.
Yes, the one in front. Very good. Mm-hmm. What is it called, everybody? Coefficients. Yes. Help a brother out. Coefficients. Number 9. What's the difference between a coefficient and a subscript? Yeah. Thank you, Seamus Brown. Gold star. That's right, though. Okay, and that's what you need to know. A coefficient is going to be the whole number. It's the whole number in front of a compound or a molecule or something, and it will tell you the number of moles or molecules that is present. Okay, it will tell you the amount of moles or molecules that's present. Okay, subscripts, on the other hand, are the little numbers that are typically down to the bottom right of a substance. So a subscript, for example, would be like H2. And it's the amount of atoms. Yeah. Okay, that tells you the amount of atoms. The amount of atoms. Okay. So coefficients tells you the relative numbers of moles or molecules present in the equation. Subscripts tells you the amount of atoms. All right. Number 10, define precipitate. As it applies to chemistry, a precipitate is a what that forms? A solid. It's a solid that forms from 2 solutions typically. Usually you're talking about pouring two solutions together. It's a solid that forms from two solutions. That's a precipitate. Number 11, write the reaction for the synthesis of ammonia. Okay, write the reaction for the synthesis of ammonia. Okay, so if we're talking about a synthesis reaction, first of all, that's one thing you need to watch out for. If it's synthesis, you already need to get in your mind, what's this supposed to look like? What's the setup for synthesis? James? Yeah, two reactants and a single product. So an A plus B, yields an AB. Okay, right? So if you know that and they're telling you how would you synthesize or how would you create ammonia NH3, where would the NH3 go? Yeah, that's right. It goes over here on the right side because they want you to synthesize ammonia. They want you to create NH3, right? Okay, so having said that then, this is just made up of two things, right? So what would you write over here? So, and when we write nitrogen, you got to think it's part of the band. So N2, it's diatomic, right? Plus what? H2. Both of those are diatomic molecules. So that's where it throws a wrench in the whole thing because now we have to go back and balance it, right? So it is nitrogen plus hydrogen reacts to form ammonia. Now, how would you balance this really quick? 2 there, 3 there, right? So that should do it. 1 to 3 to 2. 1 to 3 to 2. Okay. All right. So that's a synthesis reaction. If I ask you to write the decomposition of ammonia, you would do the same thing except flip it, right? Good. Okay. So for the following reactions, so we're looking at number 12 now. For the following reactions, gotta see what time it is. Balance and identify the reaction type. Okay. So let's start. And I haven't looked at these yet, so I don't know if we can balance them or not. Can you? Did you guys try them out? Okay. All right. If you tried out number 2, the second one, if you haven't tried that one yet, it's going to blow your mind. I had trouble with that one. I won't be putting one like that on the test. Yeah, it's did you get that one right? Did you?
Oh, I don't know.
You got it?
Gave up or got it right?
Ooh, yeah, I know. Oh, I gave up. And first hour, I had to be like, does anybody actually know the right answer? And Dagan Russell, can you believe it, of all people? No, Seamus.
What was the right answer? 2 AL aluminum and 3 that one. And then aluminum.
So are you looking at like the second reaction there?
Yeah.
I don't have them written down. I don't know. Did anybody do this yet?
I was one.
You did that one?
Are we on 2?
Yeah. What'd you get, Michael? Did you do that one?
On the first one?
We're looking at problem number 12, right, Seamus?
Yeah.
The
Okay.
second one.
I had 2 AL plus 3 H2SO4 yields AL2 SO4 3 plus 3H2.
Okay. All right. Well, hopefully the rest of us got that. We're going to try it out. See what we got. But yeah, good. All right. Let's start with P4. That one. So we're on number 12. P4 plus Cl2 yields PCl3. Okay. You can totally make a list if you wanted to, and that would be a great idea to do that here. And you will have time tomorrow if you want to make a list and work these out. Okay, but I'm just going to go real quickly here. We have 4 P's on this side. To fix it, I have to put a coefficient. So I'm going to try this out and see if it works. We may have to go back and try again. So 4 P's, 4 P's. I have 2 right here. How many chlorines total do I have right here? There are 12. So how do I fix this side? What do I put? A 6, right? So there you go. There's your ratios. 1 molecule of P4, you have 6 molecules of Cl2, 4 molecules of PCl3. You understand? So if I ask you how many molecules of Cl2 were needed, 6. If I'm asking you about molecules or moles, you got to tell me the coefficient. If I ask you how many chlorine atoms are on this side, you would say 12. Atoms means you're talking about individual particles. Okay, so, all right, let's look at this one. Next one is Al plus H2SO4. Yields Al2SO4 3 plus H2, or H2, sorry, can't see. Okay, so here we go. We're gonna start this one, and I'm just gonna work it the way I would like work it in my head, okay? I would start with my aluminums and do those first. You may have to go back and fix some stuff, but I have 1 here, 2 here, so I'm gonna do 2 there. Okay, I skip the H's, I save those till last, but because I have SO4 as a unit here, and I have SO4 here all still together, I would treat it as a whole chunk. I would treat SO4 as a whole unit. So on this side, I have 1 unit of SO4. How many units of SO4 do I have over here? 3. I have 3 groups of SO4. So over here, I'm going to go ahead and put a 3 right there. So I have 3 sets of SO4. And if I do that, then the last thing I have to worry about is my hydrogen, right? How many hydrogens do you see on the reactant side? There are 6, right? There are 6. So how do I fix this side? Okay. So what you guys add? Yeah. Okay. 2, 3, 1, 3. And that's the answer you would select, right? If it's a multiple choice question, it says, what are the correct coefficient, or what's the order? You would pick the one that says 2, 3, 1, 3. That's how you would select that if it was a multiple choice option. Okay. All right. So hopefully you saw that or can see that. All right. The next question then, or the last one there, was platinum tetrachloride, or PTCl4, whatever that is. So PTCl4 yields PT plus Cl2. Okay. Man, this one should be pretty easy, right? What do we do, everybody? Put a 2 in front of the Cl2. And that should work, right? Okay, good. All right, so that's how you would do those problems. How would you fix, or how you would fix those? Okay. So let's go back to the front page and take a look now. So I'm going to go ahead and shut the video off here because the other ones are on the other video.